Inversion of single slider crank chain. We have already discussed that when one of links is fixed in a kinematic chain, it is called a mechanism. So we can obtain as many mechanisms as the number of links in a kinematic chain by fixing, in turn, different links in a kinematic chain. This method of obtaining different mechanisms by fixing different links in a kinematic chain is known as inversion of the mechanism. Types of inversions in kinematic chains: 1. 4-bar chain or quadric cyclic chain. 2. Single slider crank chain. 3. Double slider crank chain. Inversions of single slider crank chain. We have seen in the previous video that a single slider crank chain is a 4-link mechanism. We know that by fixing, in turn, different links in a kinematic chain, an inversion is obtained and we can obtain as many mechanisms as the links in a kinematic chain. 4 inversions of a single slider crank chain are possible. First inversion of single slider crank chain: reciprocating engine or compressor. Second inversion of single slider crank chain. Under these two types of applications are: first, Withworth quick return mechanism, and second is rotary internal combustion engine or Gnome engine. Third inversion of single slider crank chain. Under these two types of applications are: first, crank and slotted lever quick return motion mechanism, and second is oscillating cylinder engine. Fourth inversion of single slider crank chain. Under these two types of applications are: first, hand pump, and second is bull pump or pendulum pump.
First inversion of single slider crank chain. Single slider crank chain mechanism. This inversion occurs when link 1 is fixed as shown in the figure. A single slider crank chain is a modification of the basic 4-bar chain. It consists of 1 sliding pair and 3 turning pairs. It is usually found in reciprocating steam engine mechanism. This type of mechanism converts rotary motion into reciprocating motion and vice versa. In a single slider crank chain, as shown in Fig, the links 1 and 2, links 2 and 3, and links 3 and 4 form 3 turning pairs, while the links 4 and 1 form a sliding pair. The link 1 corresponds to the frame of the engine, which is fixed. The link 2 corresponds to the crank, link 3 corresponds to the connecting rod, and link 4 corresponds to crosshead. As the crank rotates, the crosshead reciprocates in the guides, and thus the piston reciprocates in the cylinder.
Applications include reciprocating engines and reciprocating compressors. Let us see the diagram of the first inversion of the single slider crank mechanism shown in figure. Reciprocating engine or compressor. Second inversion of single slider crank chain: when link 2, crank, is fixed as shown in the figure. Inversions occurs under this are 2 types of applications: 1. Withworth quick return mechanism. 2. Rotary internal combustion engine or Gnome engine.
1. Withworth quick or rapid return mechanism. Withworth's quick return mechanism is the second inversion of the slider crank mechanism, in which the crank is fixed. Parts used in Withworth quick return mechanism: slotted bar is link 1, driving crank is link 3. Slider inside slotted bar is link 4 at point P. Connected rod is connecting rod. And last is slider ram. In this mechanism, the slider in the slaughter bar is connected to the driving crank 3. When the crank rotates clockwise direction with uniform speed, the slider C, which is attached at the end of driving link, it will slide inside the slotted bar and the slotted bar will oscillate about pivot point B. As the slotted bar oscillates, link 5 is attached at the end of slotted link 1, which carries the ram and tool. The ram will move in a forwarding and backward direction. The return stroke or ideal stroke is faster than the forward stroke in this mechanism. The Withworth quick return mechanism converts rotary motion into reciprocating motion, but unlike the crank and slider, the forward reciprocating motion is at a different rate than the backward stroke. when the driving crank moves from position CA2 to CA1 through an angle alpha in clockwise direction, then the tool moves from R1 to R2. Angle alpha will be for cutting stroke and angle beta will be for return stroke. Since driving link rotates at uniform angular speed, the ratio between the time taken during the cutting and return strokes is given by equation.
Time of cutting stroke upon time of return stroke equal to alpha by beta. Also use equation alpha by inside bracket 360 degree minus. Also use equation inside bracket 360 degree minus beta bracket close by beta.
As angle alpha is always greater than 180, therefore ratio alpha upon inside bracket 360 minus alpha is always greater than 1. Hence time required for cutting stroke is greater than return stroke. This mechanism is most commonly seen as the drive for a shaping machine. Thus for return stroke no cutting operation is done in shaper machine. So it's quicker than cutting stroke. Hence this mechanism is called as quick return mechanism.
2. Rotary internal combustion engine or Gnome engine. Rotary internal combustion engine mechanism is the second inversion of the slider crank mechanism in which the crank is fixed. It consists of 6 cylinders in one plane and all revolves about fixed center D, as shown in figure, while the crank, link 2, is fixed. In this mechanism, when the connecting rod, link 4, rotates, the piston, link 3, reciprocates inside the cylinders forming link 1. Applications of rotary internal combustion engine or Gnome engine. Sometimes back, rotary internal combustion engines were used in aviation for aeroplane. Watch in this video. But nowadays gas turbines are used in its place. It's clearly visual how fuel burns in it.
Third inversion of single slider crank chain. When link 3, the connecting rod, is fixed as shown in the figure, this inversions occurs under this two types of applications are 1. Crank and slotted lever quick return motion mechanism. 2. Oscillating cylinder engine.
1. Crank and slotted lever quick return motion mechanism. The crank and slotted quick return mechanism converts rotatory motion into linear motion. It is extensively used in shaping, cutting machines and in rotary internal combustion engines, and is particularly useful in cutting flat surfaces out of metal stock. The return stroke of the ram is faster than the advancing stroke. In this mechanism, the link AC, link 3, forming the turning pair is fixed, as shown in figure. The link 3 corresponds to the connecting rod of a reciprocating steam engine. The driving crank CB revolves with uniform angular speed about the fixed center C. A sliding block attached to the crank pin at B slides along the slotted bar AP and thus causes AP to oscillate about the pivoted point A. A short link PR transmits the motion from AP to the ram, which carries the tool and reciprocates along the line of stroke R1 R2. The line of stroke of the ram, IR1 R2, is perpendicular to AC produced in the extreme positions. AP1 and AP2 are tangential to the circle and the cutting tool is at the end of the stroke. The forward or cutting stroke occurs when the crank rotates from the position CB1 to CB2 or through an angle beta in the clockwise direction. The return stroke occurs when the crank rotates from the position CB2 to CB1 or through angle alpha in the clockwise direction. Since the crank has uniform angular speed, since the tool travels a distance of R1 R2 during cutting and return stroke, therefore travel of the tool or length of stroke equal to R1 multiplied by R2 equal to P1 multiplied by P2.
The difference between the crank and lever mechanism and Whitworth mechanism is that in Whitworth mechanism the return stroke is faster than forward stroke, while in the crank and lever mechanism the forward stroke is of the same speed as that of the return stroke.
2. Oscillating cylinder engine. The arrangement of oscillating cylinder engine mechanism, as shown in figure, is used to convert reciprocating motion into rotary motion. In this mechanism, the link 3 forming the turning pair is fixed. The link 3 corresponds to the connecting rod of a reciprocating steam engine mechanism. When the crank, link 2, rotates, the piston attached to piston rod, link 1, will reciprocates and the cylinder, link 4, oscillates about a pin pivoted to the fixed link at point A.
Fourth inversion of single slider crank chain when link 4, the connecting rod, is fastened. This inversion occurs under these two types of applications are 1. Hand pump, 2. Bull pump or pendulum pump. 1. Hand pump. In this mechanism, the inversion is obtained by fixing the cylinder or link 4, i.e. sliding pair. Hand pumps are a type of human-operated positive displacement pump. They are a common sight in many rural areas where piped water connections do not exist. Hand pumps have a simple and robust design, require little maintenance, and are easy to operate. This has led to their widespread application throughout the world. Hand pump components. A hand pump consists of relatively few parts, but the number and type of parts depend upon the individual pump design. Different parts hand pump are shown in figure: suction inlet, cylinder, discharge, piston, piston rod, handle or lever, and foot valve. Water is drawn into the cylinder as the pump lever is pressed downwards. Pressing the pump lever downwards causes the piston to move upwards and the foot valve to open. The piston non-return valve is closed as the piston moves upwards. Once the piston has reached its highest point of transit, the operator pulls the pump lever upwards. Pulling the pump lever upwards causes the piston to move downwards and the foot valve to close. The piston non-return valve is open as the piston moves downwards. The result from this movement is that water from the underside of the piston non-return valve is moved to the top side of the piston non-return valve. When the piston next moves upwards, it moves the water that is now present on its top side upwards also. Repeating this push and pull movement on the hand pump lever results with more liquid being drawn into the cylinder and the water level within the cylinder rising. As the water level rises, it reaches the height of the discharge pipe and begins to flow out of the pump.
2. Pendulum pump or bull engine. In this mechanism, the inversion is obtained by fixing the cylinder or link 4, means sliding pair, as shown in figure. In this case, when the crank, link 2, rotates, the connecting rod, link 3, oscillates about a pin pivoted to the fixed link 4 at A and the piston attached to the piston rod, link 1, reciprocates. This type pumps, which is used to supply feed water to boilers, have two pistons attached to link 1, as shown in figure. Total kinematic pairs in this pendulum pump or bull engine mechanism are: first, turning pair between piston and piston rod and connecting rod. Second, turning pair between connected rod and crank. 1. Sliding pair between piston, piston rod and cylinder. Third pair between is turning crank and cylinder. The mechanism is used in duplex pump in boilers and also in manual hand pumps fitted on bore well.
Thank you very much for watching full video. Please subscribe, like and share channel. PGK Kadam Academy.